What's up, folks? Today we're going to be looking at the Skyrich Lithium Ion. It's actually a LiFePO4 battery. It's a motorcycle or power sports battery. I assume you could also use it in like a riding lawnmower or something like that. It's right about that size. But this battery has failed. It's failed to the point that it's at around 10.5 volts. And whenever you put the charger on it, it will jump right up to 14 volts. And then the charger will stop as if it's fully charged. Even though I know it's not, you disconnect the charger, it will very rapidly drop right back down to 10.5 volts. And at 10.5 volts, that's right about the range I would expect if there was just a single cell group lost. So today we're going to tear into this, see what type of cells it has, and we're going to see if we can find some matching cells. We may have to do a capacity test on one or maybe even a few of the remaining cells, just so we can find a suitable match, because if we buy a new cell that has closer to its rated capacity, or at minimum its rated capacity, you want to make sure, well, and even still your cell internal resistance will be different, but you want to match the cells as closely as possible. But anyways, we're going to rip into this thing. I don't think it's going to be too pretty. I did try already just to see what I was dealing with. And this flap here did peel off fairly easily. And I did hear the glue breaking. So I'm hoping it's not too much of a pain in the ass to get into this. But we're about to find out. Alright, so before we get right into it, as you can see there, when I press test, it just says battery voltage low. If we check the voltage here, bring the meter into view, this will be reverse voltage, but whatever. So you can see 10.6 volts there, which, like I said, is right about what I'd expect to see if we lost a single cell group. So now, time to try and get into this battery. Wish me luck. I can see this is going to be pretty destructive before we end up getting this off, which is kind of exactly what I've expected. It's pretty much always that case. What I am hoping is that there's an inside lip, because it's very typical that these types of cases, the way they're glued, usually end up destroying this whole outer lip. But I do plan on possibly replacing these cells if it looks like it's worth doing even. So if it is, I would like to reseal this battery up again. So hopefully there's some kind of mating surface there for us to be able to seal it again. Kinda seems like it with the way it's holding on. Alright, folks. Well, this changes things. This was not what I was expecting to find inside of this. Come on, release. There we go. There is a pouch pack. Alright, so a little bit of a jump cut there, because I was quite surprised to see a pouch pack. I did go ahead and cut off the blue outer wrap, just to verify 100% that it was a pouch pack. I was just a little confused because pouch packs for LiFePO4 are quite uncommon, and they'll usually just use cells in these types of batteries. So I just never even considered the possibility of a pouch pack being inside of this battery. With that being said, it's going to completely change this whole situation. It's not going to be as simple as replacing just a cylindrical cell. I'm not used to dealing with pouch packs at all, and quite honestly, it might be a bit of a hard time to find a LiFePO4 pouch pack of this exact size and spec compared to just finding a cylindrical cell of LiFePO4. That's usually a lot easier. But I do have another LiFePO4 battery, a larger one. It's one of the old Valence batteries that I have. It also has a dead cell group in it, and it does have cylindrical cells. So there's a possibility that I can use some of the remaining good cells in the battery to at least make a smaller battery, because I'll be removing the dead cells. So I can use some of the leftover cells to repopulate this case, since I already have it, and bring this battery back to life anyways, and get one decent battery out of both of them. So if we go and check the voltage on the cell group here, let's try and find the dead cell group. Just for shits and giggles, I know I'm not going to be replacing just one of these pouches anymore, but let's have a look here. So starting from the negative side, the first cell group right at 3.3 volts, pretty good for lithium phosphate. Alright, 3.36, also good, but as you can see it was slightly different. So the balancing board did the best that it could. There's our dead cell group there right at 0.6 volts. So it does hold a tiny bit of voltage, but obviously that cell group is dead. Now if I was just to make a guess, based on the bulging, this one is bulging a lot more than the other side, from what I can see. So we're looking for the red. Let's see where the red goes. Well, obviously the red is going to go right to the same as the red, which, yeah, is that cell right there, which, considering there is 8 cells here and it's going to be a 4S, it's going to be this group of 2 cells here. So it's possible that I would assume it would be this this back pouch is probably still good, but because this one is connected in parallel, anytime we try charging it, it's just going to drain this battery down immediately. But that's probably why we see 0.6 volts. Maybe that's I'm not too great with the chemistry, but maybe at that point this this pouch stops draining it. Looks like they use decent, looks like tinned copper, high strand count, silicone jacketed, 200 degrees Celsius rated wire, 8 gauge wire. So that's a nice touch. I don't like the fact that the pouch pack is so small for the case that it's in, and the price for these batteries I believe is above 300 Canadian dollars, so to me that seems like a large waste of money for what you're getting, and I think many people would agree with me on that one. But I guess the product is worth the value that someone's willing to pay for it anyways, so, and people paid for it. I never bought this. I got this as a recycled battery, but it did still work when I did first get it. It worked for maybe a year and a half, 2 years before it started doing this where I couldn't charge it, and it's just been sitting around for quite a while since, so figured I'd take it apart and see if there's anything we can do to fix it. And like I said, there is still hope for this battery, even though it's a pouch pack. It's and it's not easy to just replace this pouch with an identical replacement. We are going to go ahead and use these cells out of the Valence once I tear that one apart. That will be the next video that will be coming. I gotta tear into the Valence battery. It's going to be very similar to tearing into this one. I'm sure there's going to be some destruction of the case, but we're either going to end up using the Valence case or this case with one of the BMS's. This BMS doesn't actually control output. It just balances the cells, and that's probably because this battery does have a current rating of 360 amps, and a BMS capable of handling that type of current is very expensive and probably wouldn't fit very well in this space here. So with that being said, there's also no cutoff protection. So if you short this battery, if you were to short this battery, even though it is lithium phosphate, it probably wouldn't be a good time, especially with these 8-gauge leads. They definitely can handle a decent amount of current, especially at this short lead length. So there would be some meltdown, I imagine. Just for shits and giggles, let's rip this tape off. Just have a look at the pouches here. See what we can see about the way they build their pouch packs. First thing I notice is they have the contact points laid on fiberboard like PCB. That seems pretty stout for durability. Copper tabs. By the looks of it right here. The pouch pack has direct copper tabs right out of the cell. That's a nice touch as well. I still don't see $350 though. Does look like a well constructed battery. But like I said, $350 is a lot of money, considering the size of LiFePO battery that you can get for that price on Amazon, for example. Mind you, completely different application. The important parts are a lot more. Yeah, this is interesting. So from what I see, the fiberboard, it's got these slits in it where the tabs from the individual pouch packs will come up through it, and then they just load that baby with solder. Does look fairly well put together. Decent amount of solder. I don't think I would like to be running 360 amps out of this for any amount of time. Mind you, the 360 amp rating, considering it's a motorcycle and power sports battery, is just for starting purposes, and the starting cycle is usually pretty short. So this may be alright, but still, that's a lot of current to be putting through that amount of contact. So I believe what I'm going to do with this battery is unsolder these leads, cut all the balancing connectors, all the balancing leads off, and keep the balancing harness there. I always hoard all of these little things, I don't know why. I have too many of them already, but I will end up keeping that, and maybe I'll use it with whatever we replace and put in this box later on. And then I will safely dispose of this battery. I will wrap it up nicely in some tape and send it off to a battery recycler. Alright, so quick update, folks. I just so happened to look up lithium phosphate pouch packs because honestly I've never even considered them, because I've just never seen them, at least not in a soft pack. You usually see them in the prismatic cells, and the reason for that I'm going to get into now. So I've already cut the leads and wrapped this up ready for recycling, but the way this battery was installed was just like this, and that was the reason the battery failed. The battery was wrapped in the blue heat shrink. That is one thing to be mindful of, and I'm going to explain the reason now. So upon my research, the reason you don't see lithium phosphate soft pouch cells is because they require compression. Now regular lithium ion, which we always see soft pouch cells, that's what's in the cell phones, in also in pretty much all electronics, use the pouch cells as compared to the cylindrical cells. So it's very common to see these pouch cells for lithium ion, but the reason it's not so common with lithium phosphate is because of the compression required. So lithium ion requires like 0.5 to 3 psi of compression on the pouch cell, and that's just to contain the expansion and contraction that happens during charging and discharging. So lithium phosphate, on the other hand, requires 3 to 9 psi of compression to avoid bulging and to avoid deterioration and degradation. So that is the key problem here. 3 to 9 psi is quite a bit of pressure, and that heat shrink was not providing that. And seeing how this was in the case with the cells in this orientation, this is the largest surface area of the pouch, so all of the expansion is going to be in this direction here. So this case did not provide any form of compression, nor would it have even this way. It would have provided a little bit, but possibly not enough still. So what happened, which we already know, it is the outside cell group, one of the outside cell groups that died. And if I remember correctly, now that it's wrapped up in tape I cannot tell, but I think it's this top one here. So these outer pouches, they have room to expand outwards, and that's leading to the degradation of that cell group and maybe even just that pouch. All of these middle ones, they have the compression of all of the pouches outside of them, maintaining that compression required to overcome the pressures that are built up in the pack. So with that being said, their choice of a soft pouch cell in this battery case, the way they've installed it was a horrible idea. So that one reason is the very reason their battery failed. So it was a horrible move on their part to go ahead and use a soft pouch cell. For this, they would have been much better using cylindrical cells, and I measured they have plenty of room to use some of the most common sized cylindrical cells in this. They also could have used prismatic cells, which would have been more expensive for them, but those are the larger pouch cells that are in a metal casement, and now to me it makes more sense why that's the most common way you see lithium phosphate, is because that metal case is able to contain the pressures. So that was just a little tidbit I learned right at the end there. I had no idea. You learn something new every day. But to Skyrich, bad idea on your part using that type of cell in your battery, and especially when you sell it for $350. With those cells in that orientation, it's a guaranteed failure. It's not a matter of if, it's a matter of when. So for $350, this battery's definitely not worth it. Quite frankly, for $50 it's not worth it because it's guaranteed to fail. Anyways folks, if you enjoyed, thanks for watching. Have a good one.